Hello, everyone. Thank you for being here. Today, we're going to be talking about building a serverless application with Terraform. Here, we're going to discuss the basics of serverless, what it is, how we use it, the difference between classical approach and serverless approach, and also we're going to discuss what Terraform is and how would you use it. By the end, I want to also show you how we can easily deploy an application, serverless application using Terraform. So, for those who don't know me, my name is Lopes. I'm a full stack software engineer because I like to do mostly backend and a little bit of front end, and also cloud architecture. I started my serverless and Terraform journey in my previous company, where I could start using Lambdas and other serverless applications in AWS. I'm a solutions architect associate by AWS, and I'm also Terraform certified. And for those who want to connect, there's my links and a QR code to my LinkedIn profile. Okay, so what exactly is serverless, right? Why would we use it? So serverless, in a nutshell, is the concept of outsourcing the base and management of your infrastructure. So that doesn't mean that you don't have servers, but that you are not responsible to managing nor provisioning it. You outsource this responsibility to your cloud provider, example AWS or Azure or Google Cloud. I like to call it service as a service because you are going to be interacting directly with cloud services. And these are not just Lambda functions. So in AWS, we have anything that you don't have to provision, anything directly is considered service. So, for example, API Gateway, DynamoDB, Fargate, Lambdas, SQS, S3, SES, SNS, EFS. These are all serverless services. So, serverless is also considered to be scalable because you're not provisioning anything. So your cloud provider will be in charge of provisioning this on demand for you. So as long as you keep requiring infrastructure, your cloud provider, AWS, will be provisioning that for you. So for example, Lambdas, they can be scaled until 1,000 concurrent executions at the same time. So concurrent at the same time. And if you need more than that, that means that you just need to go to AWS support and request more. Also, it's considered to be highly available because now you're not provisioning and having just one server. You can consider the whole available infrastructure for its service to be your available infrastructure. So all the infrastructure that AWS makes available for Lambda functions in a defined region is considered to be the infrastructure available for you. So here we have an example of the classic approach where requests go to a server. The server gets busy processing requests up to the maximum amount that it can process at the same time. And then once the request is done being processed, it is just freed to be processing again. But let's assume that the server is busy with the maximum amount of requests, but now more requests are coming at the same time. In a classic approach, what's going to happen in AWS is that your autoscaler load balancer will enter a cooldown period to check if it needs to provision more infrastructure for you, for example, another EC2 machine. And after it validates that it needs to provision more infrastructure for you. It's going to boot up a server, but the server also needs to boot, right? So it needs to install all the required softwares and initialize them before it's available to process again. And this can take a reasonable amount of time. For example, the default cooldown period for ECS to create new tasks is 5 minutes. This can be configured, but just so you know, it can take some time to be scaled. Whereas in a serverless approach, what happens is that as long as you need infrastructure, new functions will be, or services will be provisioned for you. For example, here we can see an API gateway that just gets requests, and then it's just new Lambda functions are just booted in order to process events. Also, serverless has zero idle capacity. And what does that mean? That means that you don't have wasted resources, because your service is only alive during processing time, and after that is just disposed of. And so you can see here, a request comes to an API gateway, then to AWS, and AWS sees it's an API gateway request, so it just boots infrastructure for you, and then it just goes to a Lambda function, goes to DynamoDB. Once after you don't pay for that anymore, SQS, and then SNS, it just push subscribers, and everything is dead, disposed after it did its job. And serverless can also be cost efficient. What do you mean? What do I mean by can be cost efficient? Because serverless is usually on the pay-per-request, pay-on-demand billing agreement. That means you're only paying for the amount of service that you're using. So how much you're using and how long you're using. So, for example, a Lambda function is charged by the amount of time that is being processed and the amount of executions that you're processing. So you want to, as long as you keep the processing time of any service that you're using to the minimum, that means that it will be cost efficient. That doesn't mean that serverless can be used for everything. For example, if you're using an API, a serverless API, it can be more expensive than a classical approach if you know that you have the expected traffic of your application doesn't change that much. But for things that you have unpredictable traffic, serverless is an amazing solution. And can be cost efficient because serverless requires comprehensive architecture design. Because you want to keep, as I said, you want to keep the processing time to a minimum, right? So instead of having a Lambda function doing everything for you, like creating and fetching and updating records, you want to separate it to the minimum responsibility as possible that you can have for a Lambda function. So here we have an example of a classic architecture that you have a server, you also have a database and a email server, right? And if you want to translate this to a serverless architecture, you would have something like this, where you would have an API gateway, a Lambda to get requests from DynamoDB, a Lambda to create data in DynamoDB, and also this Lambda can just push a notification to SNS, then to SQS, and another Lambda to process and dispatch emails through SES. You could also, in SNS, SQS, email notification, SES, you could also reduce it to just SNS because it can also dispatch emails. But I don't know, maybe you want to process and create templates and validations. So this is an acceptable solution. Okay, so let's talk now about Terraform. Terraform is what we call infrastructure as code, where you don't actually code your infrastructure, but you code the blueprint of what you want your resources to be. And with this blueprint, you give it to a server that will be in charge of creating everything for you in AWS. So here, for example, is a code that would create a Lambda function. You can see you have a file name that you'll be giving the file path for the Lambda code, the function name, some roles, the handler name, the runtime that you want to use, and some environment variables. And here we have a simpler one, which is for SNS, that here you just define with actually just the name, and you have an SNS topic. Of course, you also need to give permissions to be able to publish to SNS, but just to see the service in AWS, that's the only amount of code that you need. Terraform also gives us code reusability. We keep our code base dry. What does that mean? That means that you probably are going to be creating multiple services and similar services, right? If you need to create multiple Lambda functions and you're doing that manually, you're going to have to click around multiple times doing the same work all over again. Whereas with Terraform, you can enable code reusability to be able to reduce the amount of work you have to do. So, for example, we have locals, which are local variables that you define inside the scope of a configuration. So here we have some common tags for department, a team, and then we just share these common tags across multiple resources. We also have here on the right variables, which are external information that are passed into a configuration. Also here we have like common tags that we also just share with multiple resources. Not only that, but Terraform also allows us to make use of Terraform modules. That is when you compress or you bundle together multiple resources code and use it, transform it in then you can use it with much less code to create the same resource. Here we have a code for Lambda function that I actually use in some applications, have used in some applications, and you can see that if we need to create like 10 Lambda functions, this is quite an amount of code that we need to code to write just to get a Lambda function, right? But if we create a module, we can just do this here. You can see that I transformed this amount of code to just 5 lines of code per module, and I can just pass external variables, source, where the module is, the module that we're trying to get, the name, which is the name of the Lambda function that we want, and just the source file path, which is the path to the file for the Lambda code. Okay, so Terraform also enables us to be able to develop automation because now you as an engineer is not manually clicking around AWS to create resources. Now you just code something and give to a server to do that for you. And because we are removing the human factor of provisioning infrastructure, we also at the same time reduce the amount of errors that we might have. Because let's be honest, if you code something today in the time of 1 week, you're probably not going to remember what you called it. Even if you have a decent amount of documentation, which we probably don't, because that's the biggest lie, one of the biggest lies that we tell ourselves as software engineers, that our documentation is clear and up to date. Probably something might be missing or something might have updated in your your process that you might miss, because we are humans and that happens. But if we are using Terraform, we remove this human factor. And because we remove this factor, we also going to have consistency between environments, because if you want to deploy the same infrastructure across multiple accounts or multiple regions in AWS, as long as the regions they support the same resources, you're going to create the exact same architecture, same infrastructure. So let's say we have an account A, an engineer, and this engineer is tasked to provision some infrastructure in AWS. So the engineer goes and provisions an API gateway, provisions a Lambda function, provisions a DynamoDB table, gives some role and policies to this Lambda function, and with this, the Lambda can also access DynamoDB. But let's say this engineer is tasked to do the same thing in account B, but for some reason, he forgot or missed some policy in this Lambda function. And this will cause the Lambda to lose access to DynamoDB. And sometimes you're only gonna catch this error when this code is already in production, which can make you lose lots of money. And we don't want that, right? But let's say we have the same scenario with the same infrastructure that needs to be deployed to 2 accounts. But instead of having an engineer manually provision that, we give this to Terraform. We give this to a ISC runner that will run this code for you and will provision the same infrastructure in both accounts. Terraform is also cloud agnostic. So we're talking about AWS, but we'll learn only one language to be able to write your infrastructure as code to any cloud provider that is supported, that has a provider that support the in Terraform that is supported. So of course, each cloud provider will have its own resources, but the language itself, which is HashiCorp language, HCL, is going to be just that language that you're going to have to do. So you already know how to write variables, how to write modules, how to write locals, how to create resources, and how to run this code. But so that's what it means to be cloud agnostic. So, but if you're, for example, using only AWS CDK to create infrastructure in AWS, that means if you, for some reason, decide to or needs to create something in Azure, you also need to learn the Azure specific CDK to create infrastructure there. And also something that's really good about Terraform is that it gives us organization and documentation of our infrastructure. What does that mean? Chances are that if you're creating infrastructure and even more serverless services, you're going to have a lot of services created in AWS, right? And it can be kind of confusing to navigate through the dashboard to understand what you have already created. Whereas in using Terraform, you have everything in your code base. So if you have a centralized repository in GitHub, for example, that has your infrastructure as code there, for your main infrastructure in AWS, there is where you will be able to search everything that you need to search. So for example, here's how it would look like if you are coding something in Terraform for AWS. So you have like modules, the modules that you have, for example, for Lambda, you have your APIs, your buckets configurations, your Lambdas, providers, VPC servers, and whatever else you need in your application. This makes your life much easier when you need to debug or look for something in AWS. Also, Terraform enables you to enforce team or company standards. And this is the best way to prevent fatal mistakes, is to not allow a scenario where they can happen. And it doesn't mean that you're removing the freedom or the creativity of your team, but you're making their life easier when they need to create a new resource. Because, for example, if you need to create an EC2 machine, and this machine cannot be, for any reason, accessible to the public. It doesn't cannot be public. So you can create, for example, a module that your engineers will have to use, are going to need to use. And in this module, you say, oh, okay, this is the default security groups that you need to have. This is the default access in networking that it will have. And at the same time, you can also have third-party tools like Terraform Sentinel that will enforce during the CI phase your infrastructure requirements and security policies. So it can search, for example, okay, I cannot allow this IP range to be used in EC2 machines, for example. And last but not least, Terraform enables you to version your infrastructure, which is something really amazing that it can do. Because chances are that you're going to be using some Git repository like GitHub or GitLab. And if you commit something, if you push something and create something that it breaks, you can at any time just revert this commit. The Terraform will make sure that your infrastructure will be reverted to that commit state. And this can help you a lot if you deploy something that breaks production, for example. So, okay, now I want to demo the creation of an API. So I'm going to just show here, we have this API here, this code here with API with email. So we have 3 Lambda functions. One Lambda function for creating movie, just creating data. So boilerplate coding for receiving an event from API gateway, getting the body, parsing the body, just doing some basic validations, nothing much, just logging and just creating it in DynamoDB, and also publishing any events to SNS. And this is the code to publish the event. We also have this one for getting data. It just gets from path parameters, and then just do some validation and gets the data from DynamoDB. And this one to send an email. Just receive the event and queries for all the records because it's going to be coming from SQS. That's how SQS events are. And then just create a bunch of promises that are going to process the message and basically put in the type and sending the email. And this is sending the email through SES. Pretty simple. Okay, now we have here just a module for our lambdas. Pretty simple. We have an IAM role, policies, and the function using Node.js 22.x. We have some external variables for our lambda function. Output is what we're gonna be telling this module to make it available outside the module. So once you create it, you can just get this information outside the module. And data sources, getting the archival subfile, policy document, creating some JSON documents, and some policies. Also have some DynamoDB table with one read capacity, which is the minimum, hash key at ID, and just some source data. We have also our lambdas, that is just adding modules. So we get the module that we want. We pass the name of the function that we have and the code here. And the code is this one here, which is just boilerplate code that for an initialized Lambda. This is required because to deploy a Lambda function, it's mandatory to have code. You cannot deploy a Lambda function without code. And here's some policies to override it. The policies are this one for getting item, for put item, and SNS publish. We have another policy to allow the receive to SQS. So here we have another policy to allow sending email. For SQS and SNS, we have here messaging.tf. You can see that I have a locals just to give like a topic name, and this is used here, SNS topic. We also have the SQS with the policies that were seen here. So you can see data is data source, and then if you will want to see this one here, so SQS policy is this one here. And then a subscription, because it's required to be able to allow SNS to subscribe to SQS. You can see a policy ID you need to give, some statements that is going to allow SNS service to send message to SQS. And then here just a resource. Here I need to create the ARN by hand, because this is going to be added to SQS. And as you can see, one depends on the other, right? Because you can see that I have the SQS ARN here. So if I try to pass directly the ARN here from SQS to the policy, it's going to fail because we're going to enter a loop because one depends on the other. So to make it simple, we just create the ARN by hand. That's why we need the account ID and the region. REST API is just our API. So we create an API, we create a deployment that's to know if anything here changes. That means that this API is going to be redeployed. This is the stage. So this here means that there's going to be something /light, and then your paths. Here we have a gateway resource, which is /movies, /movies/ID. Here we're creating methods that are attached to this movie. And I just noticed that I'm not sharing it correctly. So let me just go here, and I can do this here. Yes. Okay, here is back. Yeah, so I was just saying we have the lambdas here to create data, email notification, just to send email, and a lambda to get data. Simple. And we have the IAC with the initialized code, which is the boilerplate code for a lambda function, because a lambda function requires code to be initialized. You cannot deploy a lambda function without code. Have the module for a lambda function, where we just say, this is the role, this is the policy, and the lambda function. Have output, which is the information that is going to be outputted from the module. We have variables, which is the variable, which is information that is going to be passed to the lambda function. Here, for example, the name of the function. And data sources, which is just data that needs to be processed or created to use the lambda function. I also have here an API method. This is just to create an API gateway method, because we're going to be using a lot of this many times. Integration is how we integrate this method, and here's a lambda function. And permissions to be able to access, to call the lambda function. And just some throttling to not allow it to be DDoSed for now. You can also increase this if you need. Okay, we have some DynamoDB table with the items, just seed data. You can see more seed data. We have our Lambda functions using modules and with some policies, SNS topic, environment variable. We have the policies to get data, create data, publish. We also have messaging, which is creating the SNS topic. So you can see here, we create a topic here, an SQS queue, give the subscription here, and we have the policy to be able, the SQS policy, because it's required to be able to create this subscription here. And here we're giving access to SNS to be able to send message to SQS. And you can see here that we need to create the ARN by hand because it's also used here and they cannot be created at the same time, or else we're gonna get a loop because they both, one depend on the other. So we just create the ARN by hand here. We have our REST API with our API gateway, just move this API, deployment, which is how it understands when it needs to be deployed again, the stage, which is going to be something like /live/movies, for example. And we also have our resources, which is the paths, so movies or movies ID /movies ID, movie ID. And here we create the method using our Lambda, our module, sorry. There where we pass the module path, the API ID, the method name, the method type, which is get, the resource that is attached to, which is /movie/move ID. You can see here movie resource, the path of this resource. The integration is the Lambda and the Lambda name. The execution R is the ARN is the execution ARN of our API, and just the stage name, which is the live one. We have one for also creating movies, which follow the same principle. And we have here providers where we configure our Terraform configuration for AWS. And here you can see we have, we say, use at least this version of AWS. And we have backend as free, because if you don't set this, your state, which is how Terraform knows what is already created to keep track of your infrastructure, it's going to be used local. And if you're using this in a CI environment, like GitHub Actions, chances are that you're not going to get the same machine that was used to create the infrastructure at first. So that means you're going to create a state from scratch, and then you will run into a lot of errors because Terraform will try to create the same infrastructure, the same resource, but it's already created. So it's important to use a remote backend. So this state is stored safely remotely. Here I'm using a bucket, S3 bucket, and then just giving a key. And here I provide of AWS, just say I use AWS. I'm not passing the credentials here because the credentials are being passed through environment variables. It makes it more secure. Have some variables for our configuration. And this is just some default variables for the region, for example. So we don't have to repeat use central one everywhere. And our SES to manage our email. So, okay, we have everything here. And we have just some boilerplate code for deploying our infrastructure. So deploying API infrastructure, where I just give some variables, some environment variables here using TFR. That's how you pass variables to, that's the easiest and I think the best way of passing variables to Terraform configuration using environment variables. So you just prefix this with tf_var_, and then give the variable name. And then here are just some secrets you can see here. So what you do, you're going to set up Terraform. Like here I'm just logging into AWS, initializing Terraform. This is how it will download modules, external modules, and initialize the configuration, download the state. Just for my check to see if it's correct. And plan to create a execution plan. So this is, will kind of validate if everything is in place, and you'll be also able to see what Terraform will try to create or delete or modify. And here we're just applying the configuration. Okay, so we will do just action here. And you see that I already ran a lot. So we're just going to trigger this one here. Okay, you see that it's running. So it's checking out the code, configuring AWS, setting up Terraform, initializing. You can see initializing modules and installing the providers. Then format check plan. You can see that it's the plan, that is the execution plan. And it's just trying to create everything that it needs to create. So one thing is that, so let me see if we already have to. So for SES, I'm using email identity. So AWS sends an email here, so I can verify that this is actually me. So I just do this to confirm that. And you can see that it's just some default thing, and it's already confirmed, and Terraform will just move on. You see, just creating emails. And if I go here, I can see that I have a Lambda, API Gateway, DynamoDB, CQ Service, SNS, and email, for example. So we will have a Lambda here for create movie, get movie, email notification. You can see it created 2 minutes, 3 minutes ago. The other ones are just other things. We have an API Gateway created here. We have a dashboard for our table, so we can see that we have our table here. And it also has some data, explore table items. You can see we have some data, we have the queue, we have the SNS topic, and we have the SES identity created. Okay, pretty simple. And now let me just see if I can do this easily. I think it's just a second. Just changing screens. So you can easily see me testing this API. Yeah. So now you can see here in VS Code, I have already prepared some HTTP methods. So this one here, you see this XXX, this is the ID that is created for your API gateway. And if you go to API gateway here, you can see movies. And it's not just the resource, but the stage, right? So you can see it's disinvolved here. So if I go here and paste this one here, we'll send a request. And you can see that I have hello from Lambda. Pretty simple. And now we'll deploy the Lambda. So I will just do X, just deploy this one here. The good thing is that deploying the Lambda is much, much faster. So I will deploy everything to save time. And if I go to all workflows, just zipping the Lambda and using AWS CLI to deploy it. So if I try the same request now, I should get the first movie. Now, if I want to create data, I can just do this here, and I will send this request here. And you can see that it created data. And if I get this ID here, and use it here. You can see that I did this. And you can also see that the email notification Lambda is also working because I received an email here. It's just because it's spam, but this is the template that we use to deploy and send emails. And that's it. Pretty simple. It's pretty fast to deploy new applications. If you need to change anything, you will just go inside your Terraform code, and you say, oh, okay, I don't want this to be action anymore. It needs to be sci-fi, right? So what you do, you just save this, and you're just gonna commit and do like changes, because that's the most descriptive message that you can do. And you will see that this should be picked up soon. Yeah, you can see that should be picked up soon. So it's going to set up, initialize, formatting, and then it's going to create a plan. And you can see this. It matched against my state in S3, and so okay, the configuration that you provided has this change. So I'm only going to do this. I'm only going to update this in AWS. And if I go now to the items here, you can see that this one here is commented, right? It's action and comment. But if I update this, you can see that now is sci-fi and comment. Pretty simple, pretty straightforward. And it's all documented and saved and versioned in a GitHub repository for you. And that's it. This is the architecture that we just deployed. You can see that it's kind of complex, but with help of Terraform, it became much, much easier to do this. So if you have any questions regarding this, you can always contact me. You saw my my contact information, my LinkedIn information. And here are some resources that you can use. The application that we just deployed is available on my GitHub. You can also check there. I have these slides in this second URL here, tinyurl.com/AndreLopes API days. You can see the documentation for Terraform modules and resources in the third URL. And in the last, you can see documentation for Terraform. So thank you very much. I hope you enjoyed it. I hope you learned something. And if you have any questions, just contact me.